Welcome to Chemistry in 10 minutes. All matter is made of atoms. Atoms have three parts. They have protons and neutrons inside a nucleus. Then they have electrons, which float around outside and move really, really fast around your nucleus. Protons are positive, electrons are negative, neutrons are neutral. For our sake, we are talking about neutral atoms right now. What that means is that our protons, positive, equal our electrons, which are negative. I just drew a hydrogen. The reason I know that that is a hydrogen atom is because I drew one proton. All hydrogen atoms, all the time, always, 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 have one proton. That's called the atomic number. It's on the periodic table. Okay, this is a periodic table. It's a giant one inside my classroom. You can't miss it. You look at it every day. Atomic number. Here's the H for hydrogen. See the little one? It's either normally above or below it, but that's the atomic number. Stands for number of protons. It's always 1 for hydrogen. So, I'm going to give you an example real fast. We're going to talk about sodium. Symbol's Na, because it's a weirdo. Its atomic number is 11. And if you don't believe me, go look at a periodic table. It says Na with an 11. What that means is there's 11 protons. So inside the nucleus of a sodium atom, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons. For our sake, we're going to say there's 11 electrons as well. Electrons go around your atom. Don't worry about why I'm drawing it like this. It will make sense in a couple seconds. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Next one I'm going to give you is chlorine. And again, I'm giving you these two examples for a reason. Chlorine's atomic number is 17. Again, don't believe me? Go look at a periodic table. It's 17. Inside your nucleus, that means you have 17 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Around your nucleus, you're going to now have 17 electrons. 2, 2, 3, 4, 5, 6, 7, 8. Okay. So there's my 17. Next thing we're going to talk about is valence electrons. Valence electrons are really important in chemistry. Valence electrons are the outermost electrons in an atom. What that means is that they are the outermost electrons. Sodium has 1 valence electron. Okay, it's the only electron in the outside shell. Chlorine, outside shell, has 1, 2, 3, 4, 5, 6, 7. Now there's a really, really easy way to figure out how many valence electrons an element has. And it's based off a periodic table. I'm really sorry for my crappy drawing. Every element in the first column has 1. Every element in the second column has 2. Don't worry about the middle, they're weirdos. If you move over to the bigger hunk, this column has 3, this column has 4, 5, 6, 7, 8. Sodium on the periodic table falls about right there. It's in the first column, therefore it has 1 valence electron. Chlorine falls roughly right there. It has 7. And as you can see, I drew 1, 2, 3, 4, 5, 6, 7. The reason valence electrons are super, super important is because they make an atom stable. Stability is super important. Okay, that's the goal of every single atom in the entire universe, is to become stable. How they become stable is they want 8 valence electrons. how they're going to get to 8 is they're either going to share electrons with covalent bonding, or they're going to transfer electrons with ionic. Okay, we're going to do ionic bonding first. Ionic bonding means they transfer electrons. So remember, 8's the magic number. We're trying to get to 8. Now, for those smart people out there, you might have already realized that sodium has 1, chlorine has 7. 1 plus 7, 8. Magic number. For ionic bonding, what's going to happen is one of your atoms is going to give the electron to the other. So now, both of them have 8. Now let me show you how that works. Chlorine clearly has 1, 2, 3, 4, 5, 6, 7, 8. Yay, it's happy. Sodium, this one doesn't exist anymore. So that means there's none in this outside shell. So it goes away. But the shell underneath it becomes the outside layer, and it has 1, 2, 3, 4, 5, 6, 7, 8. Yay! 8. What that does is that creates a bond between those two atoms, meaning it connects them together. All right? And the molecule you just made with an ionic bond is sodium chloride, which is actually salt, what you eat. Okay? Bonding type number 1. Bonding type number 2 is covalent bonding. These guys share electrons. Example I'm going to give you is water. You got some oxygen and you have 2 hydrogen. Oxygen on our periodic table falls here. So it has 6 valence electrons. I'm going to draw the atoms a little bit differently. Lewis dot structure, don't worry about it. It has 6. So around the O, 1, 2, 3, 4, 5, 6. My hydrogens, which are here, have 1. So here's 1 here, 1 here. Again, magic number is 8. How they're going to get to 8 is by sharing. Oxygen will share this guy. Hydrogen will share this guy. It'll make a bond. Oxygen will share this electron. Hydrogen will share this one. And they'll make a bond. So, sorry, that's a really crappy picture. It'll actually look like this. Ta-da!